During World War II, it was the tank which gave the Soviets the ability to hurl back the invading Germans. Designed to emphasize firepower, mobility, and armor protection, their tanks soon swept the Germans from Eastern Europe in some of history's greatest tank battles. 40 years after that war, the tank continues to dominate the Soviet view of the battlefield, and the Soviets continue to design some of the world's best tanks. Tanks whose mission it will be to smash through NATO's front lines and drive deep into NATO's rear areas to seize the strategic victory. To the Soviet field commander, only armor can assure the rapid and total destruction of the enemy. It alone can achieve swift and decisive victory under modern conditions. Armor is the basic maneuver element of the Soviet Army. The Soviets currently have over 50,000 tanks in their inventory. 20,000 of those tanks face NATO forces in Central Europe, and these are backed up by the 10,000 tanks of the non-Soviet Warsaw Pact nations. While this is an impressive armor force, most of its equipment still dates from the late 50s and early 60s. Of the 5 tanks currently in the Warsaw Pact inventory, the oldest is the T-55. Initially fielded in 1958 as an improved version of the T-54, the T-55 was a technologically sophisticated vehicle. It was one of the world's first tanks to use infrared night vision equipment, and its diesel engine had much greater range than the gasoline-powered M48 Patton and Centurion. Its armor was also thicker than that found on comparable NATO tanks of the period. The T-55 is equipped with a 100mm D-10 rifled gun that has an effective range of 1,000 meters and a maximum rate of fire of 6 rounds a minute. The tank carries 43 rounds, with over half being high-explosive fragmentation for suppressing NATO defenders. The original T-55 uses a simple Stadia rangefinder, which limits accurate engagements to 1,000 meters. In order to overcome this limitation, a number of T-55s are being retrofitted with laser rangefinders and ballistic computers. Secondary armament includes a 12.7mm anti-aircraft machine gun mounted on the turret roof that is fired by the loader, and a 7.62mm coax operated by the gunner. While the T-55 was built to emphasize firepower and armor protection, it was not designed for crew comfort. Because of its small space, the crew is forced to work in a very confined space. The turret is not fitted with a basket, and the crew sits above the whole floor on seats. Additionally, even though the tank has good speed and maneuverability, the torsion bar suspension means a rough ride for the crew, further contributing to their fatigue. Fuel and ammunition are stored throughout the interior of the vehicle, and experience has shown that a penetration of the turret will almost always kill the tank. The tank carries approximately 115 gallons of fuel internally, with an additional fuel mounted in small tanks above the fenders. 2 44-gallon fuel drums can also be fitted to the rear of the tank. These are dropped prior to entering combat. The T-55 does not have an NBC air filtration system, and the crew must mask in a contaminated area. The tank is equipped with a radiation detection system, and the tank has an interior anti-radiation liner of lead cloth, which also reduces spall should the tank get hit. The T-55 continues to be the most widely deployed tank in the Warsaw Pact inventory. In an effort to save on the cost of buying new tanks, many of the Warsaw Pact countries are upgrading their current T-55 fleet with better fire control systems and possibly reactive armor. Despite its age, the T-55 can still be a deadly opponent in a close-range engagement. In order to improve on the T-55's shortcomings, the Soviets fielded the T-62. Like the T-55, the T-62 is a small tank with a cramped interior. It mounts a 115mm smoothbore main gun that has a range of 1,600 meters, and at the time, it fired the fastest sabot round in the world. The T-62 carries 40 rounds of ammunition. Because of the gun's design, it can only fire from 3 to 5 rounds per minute. When the main gun is fired in a stabilized mode, the tube automatically elevates after ejection to permit reloading. This prevents the gunner from using burst-on-target gunnery techniques and requires him to resight the gun. The gun is also equipped with a shell ejection system, which ejects the spent shell casing through a small port in the turret rear. During the 6-second ejection cycle, all turret power is shut off, preventing the gunner from tracking further targets. It still uses a stadiometric sight, but the flat trajectory of the sabot round allows him to engage at greater ranges than the T-55. The T-62 is powered by a V12 water-cooled diesel engine and has a maximum road speed of 50 kilometers per hour and a cruising range of 650 kilometers. The T-62 also mounts a 12.7 millimeter anti-aircraft machine gun fired by the loader and a 7.62 coax fired by the gunner. Like the T-55, the T-62 does not have an NBC air filtration system. It is equipped with the PAZ radiation detection system, which detects radiation from a nuclear blast. When activated, the system automatically shuts off the engine and seals the drivers and crew compartments. A particulate filter and pump is then activated to create a slight overpressure within the tank and remove contaminated dust. Once through the contaminated area, the crew must decontaminate the exterior of the tank. Like the T-55, the ammunition and fuel are stored internally, and even a glancing blow on the turret can cause a detonation. Additionally, the T-62 suspension does not provide a comfortable ride for the crew, and crew fatigue is a major problem. Many T-62s are being upgraded with a laser rangefinder and an improved ballistic computer. These modifications are designed to improve its accuracy and chances of a first-round hit at 1,600 meters. In addition, a number of T-62s have been equipped with additional turret armor to protect against light anti-tank weapons. The T-62 is a uniquely Soviet tank that was not adopted by the rest of the Warsaw Pact, but has been exported to a number of countries around the world. Despite design limitations, the T-55 and T-62 were very competitive tanks for the period in which they were introduced, and at close ranges can still be lethal opponents. Because their general outlines are very similar, the quick way to identify the differences between these tanks is to look at the location of the bore evacuator on the main gun. On the T-55, it is at the end of the tube, and on the T-62, it is closer to the center of the barrel. In addition, the gaps between the road wheels are different. On the T-55, there is a pronounced gap between the first and second road wheels, while on the T-62, this gap is located between the third and fourth and fifth wheels. Even before the T-62 had been fielded, the Soviets were working on a new family of tanks, the T-64 and T-72. While there are differences between these tanks, they share significant improvements in firepower, mobility, and armor protection. Both tanks are equipped with a 125mm main gun that has an effective range of 2,100 meters. While the original T-64 and T-72 were equipped with coincidence rangefinders, the current T-64 Alpha and T-72s have laser rangefinders backed up by advanced ballistic computers for greater accuracy at long ranges. Both vehicles use an automatic loader, eliminating the need for a loader in the crew. The automatic loader also allows the tank to maintain a 6 to 8 round per minute rate of fire for an extended period. Both tanks are equipped with an improved stabilization system for firing on the move at low speeds. And the tank can maintain its sight picture even in a 360-degree turn. The basic load for these tanks is 40 rounds, approximately half of which is located in the carousel of the automatic loader and immediately available for firing. The tanks fire 3 types of ammunition: an armor-piercing, fin-stabilized discarding sabot round, a high-explosive anti-tank round, and a high-explosive round for suppressing defenses. These rounds are in 2 parts consisting of a semi-combustible propulsion charge and the projectile. These are mated by the automatic loader as part of the firing sequence. The Soviets also made a number of improvements in the engines and suspension systems on both tanks. Both tanks are capable of speeds in excess of 60 kilometers per hour and have excellent cross-country mobility. The T-64 uses a 5-cylinder opposed piston diesel engine, while the T-72 uses a turbocharged 12-cylinder diesel. Both have cruising ranges in excess of 500 kilometers. Both tanks are equipped with the new NSV 12.7mm anti-aircraft machine gun, which is fitted on the commander's turret. In the T-64, the machine gun can also be fired remotely from inside the turret. Both tanks are also equipped with a 7.62mm coax. The T-64A and T-72M provide Warsaw Pact commanders with a new generation of tanks that are competitive with the M60A3 and Leopard 1 and have far greater capabilities than the T-55 and T-62. T-64As are assigned to the three Soviet armies facing the Northern Army Group, while T-72Ms are found in the Czech, East German, and Polish armies. In addition to the T-64A, the Soviets have also fielded the T-64B, which can fire the radio-guided AT-8 anti-tank missile. With a range of 4,000 meters and a flight time of 10 seconds, the AT-8 can engage tanks and even helicopters. The Soviets have continued to improve the T-72's armor, and several Soviet T-72 variants now exist. The most recent, the M1986, features a significantly thicker turret. The newest tank in the Soviet inventory is the T-80. Its 125mm main gun is capable of firing the AT-8, and it has a sophisticated fire control system with full stabilization for a limited shoot-on-the-move capability. The T-80 is also the first gas turbine-powered tank in the Soviet inventory and is capable of road speeds in excess of 80 kilometers per hour. T-80s are now the primary tank of the Soviet armies that are facing the Central Army Group. The T-64, 72, and 80 tanks were designed to survive on a battlefield that would see the widespread use of anti-tank missiles. Most of the armor now found on the glacis and turret front of these tanks consists of layers of steel and glass fiber that are specifically designed to defeat heat rounds like the earlier models of the TOW missile and reduce the penetration of kinetic energy rounds. Mindful of NATO's top attack weapons, many of the newer Soviet tanks are being provided with a layer of glass-reinforced plastic that is supposed to provide additional protection from radiation and bomblets. This material partially covers the rear and top of the turrets on the T-64B and the newest T-72s. Even with the specially designed armor, Soviet tanks could be defeated by the TOW-2 and European HOT anti-tank missiles. Thickening the armor would mean an unacceptable weight increase for the tanks, which would limit their battlefield mobility. Even their heaviest tank, the T-80, doesn't weigh more than 40 tons. In order to achieve an acceptable level of protection from anti-tank missiles while saving weight and reducing costs, the Soviets adopted a reactive armor box to be fitted to their entire armor fleet. Within each box is a sandwich containing two metal plates separated by an explosive charge. When a TOW missile detonates, it forms a jet of hot gases which burns through the armor. When the jet hits the explosive charge in the reactive armor box, it detonates, forcing the plates into the path of the gas jet. This reduces the missile's penetration and saves the tank. Each box can stop one missile. Any tank can be fitted with reactive armor boxes. All that needs to be done is to place mounting studs over the areas you wish protected, fit some racks to the studs, and add the boxes. On the T-64 tank, the boxes are placed over the glacis, the front, sides, roof of the turret, and on the sides of the tank. This provides maximum protection to the crew compartment from most angles of attack. On the T-80, the boxes cover the glacis and turret. While this is less coverage than on the T-64, the Soviets can add additional boxes at any time. The addition of these boxes does not alter the vehicle's overall appearance. However, at the present, only the most modern tanks in the Warsaw Pact inventory have reactive armor. Reactive armor, you must remember, works only against heat-type rounds. A kinetic energy round, such as a high-velocity sabot fired by another tank, will penetrate all of these tanks. In addition to improved armor protection, these tanks also have a number of other design improvements. They are all equipped with a plow attached to the glacis front, which can be used to dig the tank's fighting position without additional engineer support. All of these tanks are equipped with forward-firing smoke grenade projectors and can create their own smoke screens by injecting diesel into the exhaust. Unlike their predecessors, these tanks come with a full NBC air filtration system for operating in contaminated areas and have anti-radiation liners for increased protection in nuclear conditions. They also share a number of features with the previous generation of Soviet tanks. All can be equipped with mine plows and mine rollers for clearing a path through NATO minefields. It takes about 30 minutes to fit a tank with the devices. All Soviet tanks are capable of snorkeling to a depth of 15 feet. While this is a hazardous and time-consuming operation, all tankers are expected to be able to conduct an underwater crossing. Normally, the tankers receive an orientation in a simulator before the real thing. It takes approximately 1 hour for the crew to seal the tank and 30 minutes to unseal it. Because their tanks leak and are difficult to control underwater, most crossings are for short distances at pre-established sites. Soviet tanks have a number of liabilities. Even with the improved armor, their small size and cramped fuel and ammunition storage usually means that a penetration of the turret, or even a glancing blow, may knock the tank out by detonating the ammunition. Their size also means an uncomfortable ride for the crew, leading to a rapid loss of efficiency. This has been partially solved by the improved suspension systems on their newer tanks, but is still a problem. Finally, because they rely on infrared systems, they only have a limited night fighting capability. Their infrared searchlight and night sight only has a range of 800 meters. This may be one of the reasons why they prefer to conduct illuminated night attacks. The majority of men in a Soviet tank company are conscripts. Professional soldiers rarely number more than 10% of the company's overall strength. Tank commanders, gunners, and driver mechanics are given a 4 to 6 month course in special training companies before joining their units. Each member of the crew learns his duties by repetition until he can perform to the required standard without conscious effort. There is very little cross-training of the crew. At least one tank commander in each platoon will be a junior officer who is a graduate of a 4-year military academy and who bears the responsibility for ensuring that his platoon reaches their expected standards of proficiency. The crews are normally trained on controlled driving and firing ranges. The driver is expected to safely overcome a time series of driving hazards while providing the gunner with a good sight picture. Obstacles on the driving course include hills, bridges, steep slopes, curves, and a deep fording obstacle. The Soviets supplement their live training with extensive time in realistic simulators. This reduces costs and wear on their vehicles. Most simulator firing is done with subcaliber devices, although live firing of the coax is common. Tank gunners are expected to qualify annually. On the older tanks, such as a T-55 and T-62, firing is normally conducted from the short halt as the tank drives down the range. On the newer tanks, the targets can be engaged on the move. Most engagements use a 23mm subcaliber device and the tank's machine guns. However, live rounds are used in firepower displays for select units. Even after all this training, there is no guarantee that the crew will be able to accurately engage their targets. Warsaw Pact Army units spend several months in the field each year in fairly austere conditions. In the early phases of training, the daily routine includes a healthy round of morning exercises, usually led by the platoon leader, followed by the day's wash-up in the local stream or lake. By 0800, the battalion or company commander will give the signal to move out for the day's series of road marches throughout the training area. Halts for maintenance will be frequent, and the crews will constantly practice inspecting their vehicles and making minor repairs and adjustments, assisted as necessary by the battalion's maintenance section. Refueling will also be practiced using the battalion's fuel trucks, which can simultaneously refuel several vehicles. Like soldiers throughout NATO, the Warsaw Pact forces have their share of unannounced alerts. The procedures are basically the same. Officers and NCOs living in quarters will receive a phone call directing them to report to their units. Barracks personnel will pick up their weapons and field gear and move to the vehicle park. The entire battalion will then roll out to the local dispersal area. This is a timed exercise, and commanders have been relieved for failing to meet the timelines for clearing the caserne. Towards the end of their annual training cycle, Soviet tankers will participate in company, battalion, and even regimental combined arms operations. Normally, the tank battalion will be assigned to a motorized rifle regiment. Wire will be laid between positions in their deployment area, and vehicles will be camouflaged. The unit's junior officers will closely supervise the activities. Special equipment such as mine plows will be fitted. And tanks will be resupplied with ammunition. All unit supporting equipment, such as maintenance and fuel, as well as ambulance services, will also be carefully positioned and camouflaged. Supporting attack helicopter assets will also be prepared for the battle. As the unit makes its final preparations, the officers will be briefed by the regimental or battalion commander on his plan of attack. Normally this is done from an observation post, either fixed or mobile, that overlooks the area of operations. The battalion commander will brief his subordinate company commanders on the scheme of attack, the objective, and time of the attack. Approximately 2 hours before the attack is scheduled to begin, the units will move out in battalion column from the regimental assembly area and proceed towards the objective. The tanks will normally lead the motorized rifle formations. Approximately an hour before the ground attack begins, an intense artillery barrage will be fired on the defenders' positions using all available artillery assets. At H hour, the ground attack will begin, and units will deploy from battalion to company to platoon columns and eventually on line. Tanks and BMPs will provide suppressing fires on the defenders' positions. If the tanks and BMPs are unable to overrun the defenses, the infantry will dismount and proceed to attack on foot. Normally, the infantry on line will follow approximately 100 meters behind the tanks, and the BMPs will follow behind the infantry line. Artillery fire will continue on the defenders' position to suppress their anti-tank and heavy machine guns. Should the assault fail to carry the defenders' positions, the battalion commander will probably initiate a flank attack using one or more of his additional companies. Supported by additional artillery fires, the flank attack will sweep around either the left or right side of the defender's position. Attack helicopters will also be available to support the Soviet ground forces. Once the armor and BMPs have reached the flank of the defender's position, they will dismount the infantry, who will then commence a ground assault on that flank. Should NATO defenders attempt to counterattack, they will be met by a wall of fire from supporting artillery and attack helicopter assets. Artillery fire will continue throughout the attack, suppressing not only the defender's positions, but his positions in depth as well. Infantry supported by armor will finally sweep the top of the defender's position, and this usually signals the end of the day's exercise. Company commanders will then reform their troops and proceed either to the next portion of the day's exercise or end the exercise activities. Despite what seems to be repetitious training, Warsaw Pact tankers are very resourceful soldiers who can be expected to function on their own without extensive additional support. They are also trained to eliminate all types of counter-mobility obstacles using their own tank's organic capabilities. If a subtle approach to clearing an obstacle doesn't work, then direct firepower usually will. The Warsaw Pact's tank forces have definitely benefited from their force modernization programs of the past decade. Today, their equipment ranks with the best in the world for firepower, mobility, and armor protection. Yet even with all of these improvements, a well-planned defense that integrates minefields with anti-tank weapons, artillery, and air support will seriously threaten the success of their operations. As they continue to improve on their armor's capabilities, they will pose an even greater challenge for NATO defenders and will remain a force to be contended with on the modern battlefield.